SpaceX is actively modifying the launch tower at Pad 2 in Starbase, Texas, and two of those modifications are now either complete or nearly so. The ship quick disconnect arm has been reinforced with new steel, and a brand new roof structure designed specifically to protect the tower during ship catch operations has been welded into place. Orbital Launch Pad B, the facility SpaceX calls Pad 2, sits at Starbase in Boca Chica, Texas, and its tower, designated OLIT-3, reaches 474 feet into the Gulf Coast sky, nearly identical in height to the original Pad 1 tower. Height is about where the similarities end. Almost everything else about Pad 2 was redesigned from scratch, with one goal driving every decision: cut the turnaround time between flights and stop losing hardware to pad damage. Pad 1 was functional, and that's about the most generous way to describe it. 11 Starship flights launched from that pod, and after every single one, the infrastructure needed serious repair work. No flame trench, no water-cooled deck, no flame diverter system of any kind, and the very first Starship launch answered the question of what happens without them when the engines dug a massive hole in the concrete beneath the mount. That wasn't a pad that could support a high launch cadence, and SpaceX knew it. Pad 2's tower base alone tells the story of what changed. Where Pad 1 used a concrete base clad in stainless steel, Pad 2 flips that entirely, with a stainless steel framework filled with concrete, and the housing at the rear of the base is noticeably larger and more capable. The rigging system for the chopstick arms is different too, with Pad 2 running 6 passes of wire rope through the crown block sheaves rather than Pad 1's 5, and that one additional pass is what allows the arms to reach a maximum lifting capacity of 700 US tons, a figure SpaceX verified through load testing between May 16th and May 24th of 2025 using water ballast bags. 700 tons covers the combined mass of both Starship stages, plus payloads, plus a margin of safety on top. The chopstick arms themselves are shorter than Pad 1's, which sounds like a downgrade until you understand why. SpaceX watched Booster 12 and Booster 14 come back to Pad 1, and both caught closer to the tower than the original arm design anticipated, which meant longer arms were never necessary. Shorter arms got locked into Pad 2's design before the tower was even fully erected. Now to the first of the two active modifications, the SQD arm, and what SpaceX just did to it. The SQD arm is the hardware that physically connects to the Starship upper stage before every launch, handling propellant loading and power connections during pre-launch operations. No arm, no fueled ship, no flight. And when liftoff happens, that arm needs to swing clear of the vehicle fast enough that 33 Raptor engines don't cook it on the way up. Steel reinforcements now sit on the lower side of the arm's shoulder section, added by technicians this week, and the belief is that these changes strengthen the joint while also allowing the arm to retract faster than before. A quicker swing reduces exposure to the exhaust plume at the moment of ignition, which reduces wear, which reduces the refurbishment work required before the next flight. The core work on the SQD arm appears largely done at this point, with scaffolding expected to come down as the pad moves toward final configuration. What nobody always highlights is how far along this arm already was before these reinforcements went on. Earlier in the campaign, the arm had been fully integrated with fluid lines and power connections, and the end section that physically interfaces with Starship had been outfitted at a nearby production site before installation, with mounting points for the quick disconnect plate already in place. The second modification is the one you can see from a distance, and the one that tells you the most about where SpaceX intends to take this program. A new roof structure now sits at the top of Pod 2's tower, lifted into position by the Buckner LR-11000 crawler crane that has been planted at Starbase for weeks, and as of late March 2026, the installation is visually complete and being welded into its final position. The FAA's obstruction evaluation filings had flagged crane work for this roof between February 13th and March 16th, and SpaceX completed the installation close to that window, with the structure confirmed in place by late March. Its purpose is specific. When the Starship upper stage returns to the tower for a catch attempt, it doesn't approach the way the booster does. The ship comes in from behind the tower, fires its 3 sea-level Raptor engines to slow down and what SpaceX calls a flip and burn maneuver, reorients itself, and then slides down between between the chopstick arms. And during that burn, the top section of the tower, where the drawworks system lives, where the hardware that actually moves the chopsticks is housed, sits directly in the path of that exhaust. Without protection, repeated catch operations would eat through that equipment over time, and a drawworks failure during a catch attempt isn't a recoverable situation. The new roof exists to prevent exactly that outcome, and exterior panels going up along the top segment of the tower are adding another layer of coverage around those critical components. Taken together, these two modifications point in the same direction. SpaceX isn't finishing Pad 2, they're conditioning it for high-frequency operations, which is a different thing entirely. Reinforce the arm so it retracts faster and lasts longer. Protect the drawworks so ship catch attempts don't wear out the equipment needed to perform them. Both changes serve a pad that is meant to cycle quickly, and right now, Pad 2 carries the full weight of what comes next, because Pad 1 came offline in October 2025 and is being rebuilt from the ground up. There is no backup pad at Starbase. Whatever flies next, flies from here. Flight 12 is that next flight, pairing Booster 19 with Ship 39, the first Block 3 hardware SpaceX has built for an integrated launch, and the first time Raptor 3 engines will fire as part of a full stack. On March 16, 2026, Booster 19 completed an initial 10-engine static fire on Pad 2, the first time Raptor 3 engines had ever fired together at this pad. And while the test ended early due to a ground-side issue, possibly related to water pressure in the deluge system, according to NASA spaceflight, SpaceX characterized the overall campaign as a win. Booster 19 is back at the production facility now, receiving the remaining engines, with a full 33-engine static fire still ahead before the vehicle is cleared for flight. On April 3rd, Elon Musk confirmed on X that the first V3 Starship launch is 4 to 6 weeks away, placing the current window squarely in May 2026. And this is where the broader picture comes in. Pod 2's modifications aren't a Starbase-only story. Every design refinement developed here, from the new OLM architecture to the reinforced SQD arm to the ship catch roof, is being replicated at Launch Complex 39A at Kennedy Space Center and at Space Launch Complex 37 at Cape Canaveral. What SpaceX learns operating this pad shapes every Starship facility that follows. So here's where things stand. The ship quick disconnect arm has been reinforced at its shoulder section to improve retraction speed and structural durability. The roof structure, built to shield the tower from ship exhaust during catch operations, is welded in place and complete. Both changes reflect the same engineering logic: protect what matters, cut the time between flights, and build the pad to last through repeated operations rather than just the next one. Flight 12 is targeting May 2026, and when it launches, it will be the first V3 Starship, the first launch from Pad 2, and the first real test of everything that has been built, modified, reinforced, and welded into place at this tower over the past 2 years. The pad is ready. The modifications are done. Now it comes down to the hardware.